Hello everyone. Now today I want us to look at the factors that affect capacitance of a capacitor. But before we look at the factors, we have to know what a capacitor is. Whereby we're saying a capacitor is a device that stores, the main word here is stores electrical energy by accumulating electric charges on two closely spaced surfaces that are insulated from each other. So here is the symbol of a capacitor, whereby we are saying it has two closely spaced surfaces. This is the first plate, this one is a plate, then the other plate is here. So we are saying they are insulated from each other. So this space here that is here, we call it a dielectric, which is an insulator. So this is the part that separates the two plates, and it is called a dielectric, and it is an insulator. So capacitance is the ability of a capacitor to store electrical energy. Capacitance is the ability of a capacitor to store electrical energy. The unit of electrical capacitance is the farad. Farad, abbreviated as F. Farad. Now, the factors that affect capacitance, we have three factors here. We have three factors. The first factor is the type of dielectric material. The second factor is the area of the plates. The third factor is the distance between the plates. Now, with these factors, we shall be focusing at the diagram here. Now, the type of dielectric material, here we mean the space here between the two plates is covered by what? This part is the part which is occupied by the dielectric. We have said the electric here is an insulator. It could be a piece of paper, so long as it is an insulator, or a plastic, it could be air. So we are saying the type of dielectric material. So we are saying greater permittivity of the dielectric material gives greater capacitance, while lesser permittivity of the dielectric material gives a lesser capacitance. Now the next factor is the area of the plates. This is the plate and this is the second plate. So we're talking about the area, the cross-sectional area of each plate. The cross-sectional area of each plate. So larger plate area results in more field flux, that is the charge collected on the plates, hence larger capacitance, while a smaller area results in lesser field flux and hence lesser capacitance. So the larger the area, the larger the capacitance, while the smaller the area, the smaller the capacitance. So in other words, we can say that the area of the plates is directly proportional to the capacitance of the capacitor. Now, lastly, the distance between the plates. If we talk about the distance between the plates, we mean this distance here. I've named it D. The distance D between the two plates, this distance here. It is the one we are talking about. So we are saying further plate spacing gives less capacitance, while closer plate spacing gives greater capacitance. So here we mean the closer the two plates, the higher the capacitance, while the further the two plates, the lesser the capacitance. As you put them aside, you reduce the capacitance. As you bring them closer together, you increase the capacitance. So the distance between the plates, we can say it is inversely proportional to the capacitance of the capacitance, because as the distance increases, the capacitance reduces, while as the distance reduces, the capacitance increases. So we have a note here, take note. We're saying the type of the electric material can also be called the ability of the dielectric to store electrostatic forces. So instead of saying type of the electric material, you can also say the ability of the dielectric material to store electrostatic forces. Now the area of the plates can also be called the cross-sectional area of the plates, while the distance between the two plates, can also be called the thickness of the dielectric. I've said the dielectric is the insulator which will be used here. So the thickness of the insulator can also be called as the distance between the two plates. So these are the three factors that affect capacitance generally: the type of the dielectric material, whereby you can also say the ability of the dielectric material to store electrostatic forces. The second factor is the area of the plates, and the third factor is the distance between the plates, which can also be referred to as the thickness of the dielectric. Kindly guys, do not forget to subscribe to this YouTube channel, like, comment and share these videos.